Hello, everyone. My name is Kelly Hall. I'm a marketing coordinator for ALS North America. I want to thank you all for joining us today for our Webinar Wednesday series. Our presenter today is Tim Crowther. A little background on Tim. Tim received his Bachelor of Science degree in chemistry from King's College London in 1988 and a Master of Science in Analytical Chemistry from the University of British Columbia in 1991. He is a chartered analytical chemist with more than 25 years of experience in this field. Also, Tim is the chairman of the BC chapter of the Canadian Council of Independent Laboratories for the Environmental and Life Sciences Division. He also volunteers on the BC Enhanced Water Quality Assurance Steering Committee and is also a member of the North American Metals Council Selenium Working Group. And now Tim serves as the Regional Client Services Manager for Canada at our ALS Vancouver laboratory. And today, Tim is going to be discussing arsenic speciation. During this presentation, feel free to use your Ask a Question or Raise Hand features. During the presentation, we might, depending on the question, save some of those for at the end, or feel free to write them in the chat box throughout the presentation. Tim, thank you for taking your time today to deliver this presentation. I'm going to go ahead and turn it over to you.
Thank you very much, Kelly, and welcome everyone. So today I'm going to be talking about arsenic speciation, and I'm going to narrow it down by using a case study. So it gives you an example, really does highlight an example of where speciation is important and where it will allow you to manage your project. So let's start off just with a safety moment, and it's an important one because it does involve arsenic, and obviously people know the history of arsenic. It's been talked about in many movies as a way of getting rid of somebody, and it's a fairly toxic poison in certain forms. So very important to read your SDS, safety data sheet, when working with samples and reagents related to arsenic. Just a general note, vary your food and drink. I will show you why later, but definitely different levels of arsenic in the same types of food. So make sure you buy different brands and change your diet and vary your food as much as possible when it comes to arsenic exposure. In about 2015, I think FDA also announced 100 ppb action level on rice and cereals. And there was a lot of talk about apple, grape juice, wines, ciders, beers, and the arsenic level in those. But as of yet, still there's been no action on that. But I'll show you again why, again, speciation can help you make the determination of whether those foods and drinks are safe to use. Just a reason for the little finger there with the "don't bite my fingernails." So it's also very important to know that arsenic does actually store in nails, in hair and nails in your body. So when your parents said "don't bite your nails," listen to them. It's very good advice. So I'm going to present a case study in Northwest Territories in Canada. It's a long, certainly got a long and notorious and rich history, which is the Giant Mine, which was one of the richest gold mines in the history of Canada. So it's with almost 10,000 ounces of gold produced in 1 year in 1948 alone. And it produced approximately 237,000 tons of arsenic trioxide, which is currently permafrosted in caverns under the mine. And it's reported to be enough arsenic to kill everyone on the planet. So this is probably a very good case study to give you an example of how to manage worker exposure. And I'd like to thank at this stage as well Parsons, and especially Greg Ertel and Caroline Serhal. They were the managers, project managers for this project, and a lot of the photos are courtesy of them. So the project involved dealing with local and federal governments as they were going to decommission the roasting complex from the giant mine site. So this was the area where a lot of the arsenic trioxide had been created. Although a lot of the arsenic trioxide had been removed and put in caverns, of course, there's a lot of it still all around the structures and also around the soil and area surrounding the site. So in the end, 2 million kilograms of arsenic trioxide were actually removed from the roasting complex. That was part of the decommissioning. So got these constructed. A lot of local labor was used, using a lot of indigenous nations who also obviously eat and drink local food and water, which is important part of the study. And in order to manage the site, the Parsons used a biological exposure index of 35 micrograms of arsenic per liter, monitored in urine. So we were going to take worker urine samples and control their exposure by monitoring the arsenic excreted in the urine. And the results needed to be reported very quickly. So there was also a challenge. We're in a remote site in Northwest Territories. Well, not remote, but it's in the far north. And you can only fly samples out of there really to get to the labs. And so had to be coordinated very well. And the reason is that you wanted to provide results so that the workers can go back to work. So that was another part of the challenge, and also a reason for why certain instrumentation is used and better than others. So some of the analytical challenges I mentioned was not just the arsenic trioxide and the dust of that, and but also that arsenic is in a lot of foods, a lot of drinks. It's present in cigarettes at about anywhere from 12 to 42 micrograms of arsenic per cigarette. Just to give you an idea, rice, it's in anywhere from 55 to 568 ppb is the range found of arsenic in rice. Apple juice, it ranges from 1 to 16 ppb. And grape juice, it ranges from 5 to 25 ppb. But some of the other things that are on this picture are on the top right-hand corner is also Labrador tea, and arsenic is quite high in Labrador tea. So that's commonly drunk in the area. You also have arsenic is present in seaweed and seaweed cakes, which are also quite a common food source for local indigenous people in the area. And of course, lots of fish and shellfish have high amounts of arsenic. Some of those arsenic forms are considered beneficial. So arsenobutane is one of those present in fish that actually gets readily excreted from the body, so it's not considered toxic. But you can imagine all of these challenges, as well as as just the environment and the dust that is all around the mine complex. So, how the project was managed was workers took urine samples both before and after their shifts. And because the site's in the Northwest Territories, we had to fly the samples to our lab in Vancouver. Then we would process the samples, and we were following a detection level or a method that can provide a detection limit suitable for the biological exposure index of 35 micrograms of arsenic per liter. And that was set, that comes from the American Conference of Governmental and Industrial Hygienists organization. That's where that number comes from. But also for the project, Parsons recommended an action level of 17 micrograms of arsenic per liter. So we were making sure our choice of instrumentation not only delivered very fast results, but also that could provide a sensitive detection limit of all the species, so that a total of 17 could be always identified. So the biological exposure index as well was based on the inorganic forms of arsenic, which are considered the most toxic, so 3 and arsenic 3 and arsenic 5, and then the major metabolites of those two species, which are monomethyl arsenic acid, or MMA, and dimethyl arsenic acid, or DMA. So the sum of those had to add up to less than 17 micrograms per liter, and definitely less than 35, but that's an action level 17 micrograms per liter. So here is just a summary of both the structure and the species of arsenic that were quantified for this particular project. You notice at the very top is arsenobutane, and that was, as I mentioned earlier, it's very common in fish, and it's also readily excreted by the body, and it's considered relatively not toxic, I guess, compared to the other forms, but it's actually not considered toxic. Whereas the 3 and the 5, and also your MMA and DMA are all considered fairly toxic. And your body tends to excrete in the methylated forms in the urine. And so it's very likely that that's a pathway of metabolism in the body. But these 4, MMA, DMA, arsenic 5, and arsenic 3, would be summed and then compared against those action levels. As I mentioned, the body often tries to methylate the inorganic forms, and that happens just through regular metabolism in the body, following this sort of pathway where the 5 is reduced to the 3, and then gets methylated to methyl arsenic acid, and then further methylated to dimethyl arsenic acid, and then often excreted. So any of these forms can be picked up in the urine. It just depends at what point they are in the metabolism, and also whether your body is able to continue to follow this pathway in removing the inorganic arsenic from the body. So the problems come when you start seeing the inorganic forms coming through in the urine, and there's no metabolism happening and no methylation happening. And therefore, that is when you will be indicating that you're probably going to have a problem with arsenic and potential toxicity of arsenic. So there are lots of techniques that have been used in the past for measuring arsenic, and we had to come up with one that was not only fast but also remove some of the common problems that are associated with arsenic detection. So the first thing is looking at a total versus arsenic species. So total arsenic is traditional way. Arsenic in waters, traditionally digested with nitric and HCl, and then analyzed by an ICP-MS. That method in regular using regular ICP-MS or inductively coupled plasma mass spectrometry, you often had interferences from the argon gas with arsenic, and these they're called polyatomic or isobaric interferences, made that not the best technique for analyzing arsenic. And more recently, there's been the evolution of both the collision cell or reaction cell ICP-MS. Doesn't involve so much argon. You can change the gases that are used in the analysis, and that can then be used to measure arsenic a lot more accurately without having to worry about some of the common interferences produced by argon. So that was one of the methods of choice. Atomic absorption was an old way of analyzing more chemically. It's involved a lot of chemistry changes if you're looking at actual speciation, but also hydride analysis with atomic absorption was often a common technique. I think now the standard is collision cell followed by collision or reaction cell followed by ICP-MS. For our particular projects, so once you've sorted out your ICP-MS detector or collision cell ICP-MS, there are also, when it comes to speciation, there are various ways of looking at that. You can have IC, HPLC, they can be coupled to high-res ICP-MS. They can also be coupled to collision cell MS and also a triple quad MS. In our situation, we focused on the instrument on the left-hand side, which is an HPLC coupled to a collision cell MS, and that provided both the sensitivity and also the speed we needed to rapidly test samples. And we also had another option available to us, yet not so rapid, which would be the high-res mass spec, which is on the picture on the right. And we could have coupled the HPLC to a high-res MS. But we felt that the collision cell was providing enough resolution and sensitivity that we could go with this option. So the method we chose was high pressure liquid chromatography coupled to a collision cell, and that's also the method that is recommended by the US Center for Disease Control. And so this sort of worked out in our favor. We used an Agilent 7700 ICP-MS, and then also an Agilent HPLC. And the detection of arsenic mass was very, very sensitive. Separation, as I'll show you, is very good. And we were able to look at all the species that we thought might be of concern for the particular project. So here's a typical chromatogram showing the elution order of the species coming from the HPLC. You see the arsenobutane eluting first, and along with some other organoarsenic species, they would often come out around there as well. And then it's followed by DMA, and then arsenic 3, and then MMA, monomethyl arsenic acid, and finally arsenic 5. And all these species we were able to detect at detection limit of 1 microgram per liter in urine. So that gave us plenty of room in summing those to make sure we're below the action level of 17 micrograms per liter, and also the exposure level of 35. So the following chart is a summary of the exposure of a particular worker, one particular worker. And it shows, it's got two lines. The first is the action level at 17 micrograms per liter. So you've got concentration is on the y-axis, and then just sampling event or time is the x-axis. And you can see that in many situations, changes to the worker job would have to be made. So maybe anything above 17 would result in doing less sites that involve the decommissioning and a higher exposure level. And then if the worker's results or urine results came back greater than 35, then the worker would not be allowed to work on the site until those levels came down. So this also required, when you had events above 35, also meant a very close look at the food and what the worker has eaten the week before, and often immediately 24 hours before, and to see whether it's something potentially high in another arsenic species, and it's just getting metabolized or excreted by the body. And so that's another reason why often a very fast sample would be taken immediately after a result above 35, just to see whether it's still there a day later or several hours later. So this chart actually gives you an idea of why the speciation is really important compared to just a total arsenic. So the one thing that's the exposure index and everything was just of 17 and 35 would be summing up all the species with the exception of this arsenobutane, which is the one in yellow. So you can see there, if this had been included in a total, which would be if you just do not use speciation for controlling these arsenic species in the sample, then you can see that often the yellow would definitely alert you. In some cases, very much so to high levels of arsenic. But often you can see the contribution was so high from arsenobutane, you're waiting for this to either get excreted or metabolized by the body. So often a fast sample after this would then see this level come back down, and hopefully not see an arsenobutane in there at all, because it's already been excreted by the body. So again, a total wouldn't really have helped make decisions quickly, and would have resulted in a lot of cases, you see in many of these cases, would have resulted in the worker not being able to work. So it was, again, a really important feature was to be able to use arsenic speciation to monitor the workers. So, mentioned food, and so I'm just going to just sort of segue into food, and the food and drink, and how important it is also to be writing down everything the workers were eating during this study. But it's also just in general, there are a lot of foods in the media that have been recognized as high in arsenic, and rice and rice products are one such food. And you can see there's actually a federal FDA limit that has been set on rice products, which is 100 milligrams per kilogram. That's what the arrow indicates here. And you can also see that if you include, in some cases, if you include that red, so if you look at just sample number 2 of rice flour there, just by including some of the organic arsenic, which might be of a harmless form, you may go just above the action limit. In some cases, and number 15, it's quite significant how much it will go above the FDA limit. So it also gives you an idea of how important it is when you're also looking at the food sources, and this could also be fish, it could be arsenic in flour products, seaweed, grains, grapes, drinks involving any of those things, so rice drinks, all of those types of food and drink. Speciation would really truly enable you to understand whether there's a toxic arsenic exposure potential or not. This is also work we did on some rice grains. Each one of these streaks on the bottom is each one of these samples is a different type of rice, and this is both the inorganic contribution and organic contribution of each particular sample. And again, if you put the 100, look at the 100 milligram per kilogram action level, you can see that many times, again, the red can tip it over the balance, and in some cases is the majority of the arsenic in the sample. It also shows that there is a vast range of levels arsenic in these products, and that's also why at the beginning I said to vary your diet. It's very good advice to take different sources and also different brands, different types of rice, basmati, brown rice. Brown rice, in actual fact, a lot of these really high samples were actually from brown rice. So the arsenic does actually is actually stored in a lot of the germ, that is the part that's often not removed in brown rice. And so again, some brown rices from some regions are a lot higher than others. And some types of rice like basmati or arborio rice also have generally different levels in them, but a wide range, and so important to vary. And the same would apply to rice products or cereal products or anything like that. It's the source rice that would affect the level that you'll have in that particular food. So one thing I did actually want to mention, just going back to this as well, was there was recently Dr. Oz. I don't know whether anybody watches Dr. Oz, but on the Dr. Oz TV show, there was a kind of a bit of a stir created from the show, because they analyzed some grape juices and apple juices, typically often given to children, but a whole bunch of grape and apple juices, and a lot of them came above, ended up with concentrations above the drinking water standard for arsenic, which was 10 micrograms per liter. And the one thing that caused problems was that the FDA actually said, well, the results are total arsenic results, and we monitor speciated arsenic. So we monitor, again, as we have done and demonstrated in this example and case study, we use speciated arsenic, and therefore you can truly assess the toxic forms. And they basically are kind of in a bit of a battle between the FDA and the Dr. Oz show, because if they had actually presented speciated results, they would see that many of those inorganic arsenic forms would have been below the 10 micrograms per liter, and that's what the FDA uses to monitor a lot of these things, food products in the US, and the same in Canada. The CFIA would use speciation to monitor any sort of arsenic-related potential exposure. So just another note is, don't always believe Dr. Oz. I don't know whether you do or don't, but in that particular show, definitely they needed to do speciation in order to provide a little bit more information to the public. So just in summary, total arsenic without speciation would definitely not provide adequate information to monitor worker exposure or exposure to both diet or the actual site. HPLC, ICP, version cell MS is a very sensitive and reliable technique for monitoring this worker exposure. Speciation of arsenic 3, 5 MMA and DMA and arsenobutane is really essential. So you've got to look at all those species to assess both diet and occupational exposure. And sample logistics and backup equipment are essential to ensure that you have fast analysis, which will enable workers to return to work safely and quickly. Thank you.
Thank you, Tim. We'll go ahead and open it up for questions. Feel free to write your question in the questions box, or you can use your raise a hand feature and you can ask Tim your question directly. We'll go ahead and give it a few minutes for any questions to come in. As people are typing their questions, I do want to remind everyone that we do record these webinars and we post them on our YouTube channel. You can just search ALS Limited to find our channel and then click on the North America playlist. We post these webinars as well as a wide variety of video resources. Again, we'll give it a few more moments to see if anyone has any questions. A few participants are saying thank you, Tim. So Adrian and Alyssa want to say thank you. They really appreciated the presentation. We do have one question that just came in from Andrew. He says, were there any unidentified species in the HPLC ICP-MS chromatograms? If so, how were these treated?
Yes, sometimes more often in the food samples, but there's often organoarsenic species that come through early on in the column, and they're treated as essentially an other organic species. We sum them up and report them as basically arsenic, unidentified arsenic species, but not in any that had been in any significant concentration. We would have tried to further evaluate what that peak was. We do a lot of that with our selenium speciation to try and really evaluate what that species might be, but we didn't have many unidentified peaks for this particular project.
Thank you. We have another question in from Ken. Is the concentration in food in mgkg or UGkg?
mgkg.
Another question from Luis. Is AS3 or ASV more toxic for the human body? I hope I'm saying that correctly.
Yep. The 3 is supposed to be the most toxic, followed by 5, and then MMA and DMA are not so toxic. They're not considered as toxic, but if your body accumulated them, I believe they would be.
We have another question from the same person. What does QQQ mean?
That's a triple quad. So that's an ICP-MS triple quad. So you have 3 quadrupoles to separate the masses of the arsenic. So it gives you greater potential resolution of a mass. Similar to a high, in some ways, a high-res MS. High-res MS uses just a lot bigger magnets and a bigger area to sort of evaluate the mass. But triple quads, you just put them through several quadrupoles, and each one separates the mass ions a little better and a little better.
Thank you. We have another question from Andrew. How were the urine samples preserved prior to shipping to the lab?
No preservation. They were just kept cold and shipped right away.
Okay, and we also have, is there a standard frequency for monitoring worker exposure?
Standard frequency. I'm not quite so sure what that means. No, I'm not quite sure what you mean by standard frequency.
Okay, that
How
question was
often
from
samples should be
Arash.
taken?
Arash, if you wanted to type in a follow-up to that question, or if you wanted me to unmute you, you can ask Tim your question. Okay, he followed up by asking, how would I know if a worker needs to do the test?
How would you know? Well, one, you have to be exposed to exposed to a source. So that's why this case study was, you have probably the biggest source of arsenic exposure. So that would be the first. So if you're in an industry where there's potential exposure to arsenic, whether it's through dust, which is the main exposure pathway at this site, but it also could be could be related to some regions. I know in BC we have some regions on the Sunshine Coast that are very they have very high natural levels of inorganic arsenic in drinking water, and so I think it depends. When you look at the total load, you have to look at whether there's a potential source from the food and diet, and also a potential source with your occupation. And putting those two things together, if there's potential for the combination to go above the 35, then I think it needs to be managed. And there's two parts to that management. So there's management of both the diet and what they're eating. Smoking is a big one as well. And again, different cigarettes will give you different levels of arsenic. And then, of course, the direct type of work that person is undertaking will affect whether they have to do less, have less impact type work. So they're doing some office type work or some work that's away from the high exposure areas. That's basically how you would manage it. So I think it has to be a combination of the first thing is you've got to have that exposure scenario, and then you also have to look to the input sources in diet and see whether that could cause an overall exposure for that employee.
Thank you. We have two questions from Lori, sort of following up with what you were mentioning, and then we'll get to Carrie's question. What sort of PPE did the workers use, if any?
If you saw the first slide, that was the PPE. So that was directly from, let me just go back there. That was courtesy of Parsons. And this worker here was the PPE required.
Perfect. Also, she asks, for the frequency, how often did you test the urine? Was it daily, hourly, weekly?
Before and after every shift.
Perfect. Thank you. Carrie asked a question. In arsenic removal in water, he says that we are in an area where arsenic is very high. What would you recommend for a water treatment system for a wholesale application? I'm sorry, a whole house application.
So you've just got a a very high arsenic source water, well water, and you're worried about your drinking water levels. Drinking water, I guess, is what your concern is. Is
I
that the
I
question?
I think so. He has not. He said yes.
Yes. So in those situations, I would definitely contact your local drinking water officer and make sure that in the case of drinking water, you have to make sure that the arsenic is below the 10 micrograms per liter. That's micrograms per liter, 10 ppb for drinking water. And if there are certain times where that, just because maybe of the groundwater level, or it could be that more arsenic at certain times is coming out of the surrounding aquifer. It's probably good to have that well regularly checked. I would only check the total arsenic until it goes above the um, 10, and then when it goes above the 10, it would be very useful to know what form that is in, whether it's 3 or 5. I doubt whether it's an organic form, but I would imagine it's either arsenic 3 or 5 typically in drinking water. So only if it goes above the 10. How often? I would say if you know it's in a region, I would say probably at least during the 2 different seasons. So if you've got a summer low level and a spring high level, I would probably look at it at both those times. So at least twice a year, I would say would probably be not a bad idea.
Thank you, Tim. We have 2 additional questions from Lisa. She asks, how often should workers be monitored when they're working in the mine area? Because we know they are being exposed already.
Oh, um, I I think I would go back down to again before and after every shift.
And another question she asked on regarding slide 17, you mentioned backup equipment. Were you referring to at the lab or on site? And if on site, what does that mean?
No, it's at the lab. Um, we have probably 8 or 9 ICP-MSs, collision cell ICP-MSs that we can move this equipment on, but it's more to allow the worker to go back to work. So if we can't provide the results, and let's say you did have a result that was above the BEI, above 35, and then you took another very quick sample and we couldn't get you that sample back, well, it may mean that that worker misses a shift of work. Maybe he cannot go to work until that result is done. So backup equipment is referring to having, it's very difficult to do this remotely, and you have more, if you have the transportation routes sorted out, which Parsons was very good at arranging for this site, so that they had known flights that they would collect the samples before they knew the flight was going out. They arranged those times for the workers to take the samples, get them to our lab in depot in Yellowknife, and then that was then shipped down to Vancouver. So we had often those samples the very next morning, and then we processed them often over the weekend so that they're ready for the next shift the next week.
Thank you. We also had she says thank you as well. Lori had a follow-up question regarding the PPE. She says, despite them having the PPE, there is still exposure. Any thoughts on how the exposure occurred?
Uh, yes, there is exposure because uh, both in the food and also in the area. So even if you came off the mine site, there is a lot of dust, especially in the summer, around the site. And therefore, again, if you're working around the site, even if you're not actually at the particular roaster complex and the decommissioning, there is still sort of dust and food and everything else around that can be contributing to the exposure.
She also asks that you said the metabolism, um, also you said the metabolism of arsenic happened. Does the body preferentially metabolize different speciations of arsenic?
I think it does. I'm not super familiar with the actual physiology of this, but certainly 3 and 5, you can see how the body breaks that down. And MMA and DMA, you can see how the body does do that. So it essentially methylates and reduces the arsenic to a form that can eventually be excreted, which is typically MMA and DMA. And some forms, I'm not even sure arsenobutane gets broken down at all. I think your body just it just passes right through your body. But it may get broken down to MMA. Sorry, um, I'm not familiar with all the various how all the different arsenic compounds might be metabolized. But my understanding was arsenobutane isn't essentially metabolized; it's just excreted.
Perfect. Everyone says thank you so much for answering all of their questions. We do not have any more at this time. So Tim, thank you again, and thank you to everyone who's still on the call for your questions and for attending. And as a reminder, we post future webinar Wednesdays on our LinkedIn page, so feel free to register there. And I hope everyone enjoys the rest of their week. Thanks again.
Thank you, everyone.